Before we get into the discussion of polynomial functions, we can start, at the basic level, which is a monomial. Then we have binomial. Then we have a trinomial. And finally, we have a polynomial. Now, you may wonder, well, what is norm? Norm means an item, a name, term in Latin. So mono would mean single. So one term. As an example, I could have 6a squared. That's by itself. So that is a monomial. Binomial, bi means two. So two terms in addition or subtraction. So I can have 6a squared plus b squared. The next is trinomial. Three terms. You can write it as 6a squared plus b squared plus c squared. Lastly, polynomial would mean multiple terms, more than three. So 6a squared plus b squared plus c squared plus 2. Now, as you look at these expressions, you may wonder, well, do the terms have to be different? In other words, should they be different variables? No, absolutely not. So it doesn't make a difference with monomials because there is only one term. I could have an expression of this sort, 6x squared plus x. That is still a binomial because it has two terms. I could have 6x squared plus x minus 4. It still is a trinomial because it has three terms. I could have 6x squared y squared plus x squared plus y squared plus 8. It's got two variables, but it has more than three terms. So term 1, term 2, term 3, term 4, it is a polynomial. So in most cases, we are interested in polynomial functions, and even a monomial we classified under polynomial functions. So degree of a polynomial is simply the highest power It is the highest power of a variable in the polynomial. Now, if I simply have one variable, for instance, if I had x cubed plus x squared minus 1, the highest power is 3. So the degree in this case would be 3. But if I had x squared, y squared plus y plus 2, then we have to look at the degree of the individual terms. So since we have x squared, y squared, the degree is the sum of the two. So 2 plus 2 is 4. Y has a power of 1, 2 is just a power of 1. So the degree here is the highest value, which is 4. Suppose we have 3 variables, a raised 4 plus a squared plus ab minus c raised 5. The power there is 4. For the second term, it is 2. Third term, 1, 1. A has a power of 1. B has a power of 1. So 1 plus 1, 2. C has a power of 5. So the degree here is 5. So if we simply had one variable, it's often easy to find the degree. But if we have more than one variable, we just have to use this process of adding the powers to determine the degree of the polynomial. So typically, we also write to denote a polynomial as p of x, just like we do a function of x. So when I write p of x equals x cubed minus 3x squared minus 8, I'm not saying p multiplied by x. This means a polynomial, hence the p, in terms of x. So the first one has only one term, so it is a monomial. If you look at the degree though, we have 2, we have 3. The biggest power is the degree if you just look at multiple terms. But here we just have one term, and the power of x is 2, the power of y is 3. So 2 plus 3, the degree is 5. The second one is a trinomial because it has 3 terms. The degree here, x has a degree of 3. The second term, degree of 4. The second term, the power of x is 1, the power of y is 3. So if you add them together, I'll get 4. 9 is just the power of 1. So the maximum or the biggest of all of them is 4. The next one is a binomial because we have 2 terms. The degree of the first term is 3 because A has a power of 1, B has a power of 2. You add them together, we will get 3. C has a power of 1, so the biggest of the 2 degrees is 3. The next one is a trinomial. the degree for the first term is 3, or the power. Last term, 3. The middle term, A has a power of 1, B has a power of 2. You add them together, the degree would be 3. So since they're all the same, the highest would be 3 as well. The last one is a polynomial. The degree of the first one is 9. The second is 8. The third is 4. I can ignore the 2 because even if you wrote something, you'll have x-ray 0, which would be 0. Don't include the power of the constant terms. So the degree here would be 9. And the last polynomial is just in one variable, which is x. And in most cases, in math, you know, at least basic level math, we only look at one variable. But as we go higher and higher and higher, we can have as many variables as we want. So we can now move to adding polynomials. I can add polynomials, you know, any number of polynomials together. But the key idea here is to combine like terms. And that is the fundamental principle, combining like terms. So here is an example. I'm going to start simple with just one variable. So 8t squared minus t plus 4. Oops. And 2t minus 4. What I like to do is to write them out like we usually do with adding numbers. Again, this is not necessary once you have enough practice. But when you're learning it for the first time, it's best that we do it this way so that we can understand it better. So I'm adding the 2. So you can see that I put like terms, you know, p and t, 4 and 4. T squared, I have none, so I'm just going to put 0 there. So 8t squared plus 0 would be 8t squared. Minus t plus 2t is simply t. 4 minus 4 is 0. So the answer is 8t squared plus t. Easier approach would be to always put the lengthier polynomial on top and the shorter polynomial in the bottom. So in this case, we have only 2, so I'm going to put the longer one on top. That's always the good way to add polynomials. So now we want to add 2 polynomials. The longer one is the first one, so 4x cubed plus 5x squared plus x plus 1. I'm going to add the second polynomial to it, so 4x cubed. The second polynomial does not have an x squared term, so I can just put 0 there. The second polynomial does have an x term, so minus x. And lastly, plus 2. So 4x cubed plus 4x cubed is 8x cubed. 5x squared plus 0 is 5x squared. The x and the minus x would get cancelled. And 1 plus 2 is 3. So combining like terms, in this problem, we don't have a longer polynomial. They're of the same length. So I'm just going to write the first one as is. And I look at the second polynomial. I have an x raised 4, but there is no x raised 4 in the first one. So I'm going to arbitrarily throw it on this side. There is an x cubed term, so x cubed. There isn't an x, so I'm just going to throw it on this side. And then the number 2, I have a number, so 2. And all the missing gaps, I'm going to fill it with 0. So plus 0, 0, 0, 0. Then we add 0 plus x raised 4 is x raised 4. 3x raised 5 plus 0 is 3x raised 5. Those two will get cancelled. Negative 2x squared plus 0 is negative 2x squared. 1 plus 2 is 3. 0 plus x is x. It's all jumbled right now, but if you see the answer that came in chat, we always write it in decreasing powers of x. So 3x raised 5 plus x raised 4 minus 2x squared plus x plus 3. And that would be the final answer. So here we have polynomials that have two variables, a and b. We'd like to add them. So I'm going to put the longer polynomial as the first polynomial in my process. So 3a squared plus 6b squared plus 2ab plus a squared b squared plus 4. And going back to the first one, I have a 3a squared, so 3a squared. I don't have an ab squared in the polynomial that I wrote, so I'm just going to throw it on this side here. I have an ab term, so ab. I have a number, so -1. These missing space or the spaces, I'm just going to throw 0 in. And now I can directly add 0 plus ab squared is ab squared. 3a squared plus 3a squared is 6a squared. 6b squared plus 0 is 6b squared. 2ab plus ab is 3ab. A squared b squared plus 0 is a squared b squared. 4 plus -1 is plus 3. And if you look at the degree of this polynomial, it is 4, and it comes from this term right here. So I'm going to put that first. A squared b squared plus ab squared, because it has a degree of 3. 6a squared, 6b squared plus 3ab plus 3. And you may ask me, well, this term and that term and that term have the same degree. So does it matter in which order you put them? It doesn't. I just like to write it this way because I've seen how expressions are written, how polynomials are written, and experience tells me this is how I should write it. But if you wrote it in a different way, it wouldn't make a difference at all. So here we have two polynomials, and it looks like both of them have the same number of terms. So it doesn't matter which one you put first and which one you put as the second polynomial. So I'm going to start with the first one, x cubed y squared plus xy cubed plus xy plus x plus 1. I look at the second polynomial, I see 6x cubed y squared. Then I have x cubed y, which is not the same as xy cubed. So I'm just going to throw that on the side here. The next one is minus 2xy, so minus 2xy. The next term is y. I'm going to throw it on the side there because the first polynomial did not have a y in it. Then we have a number, -1, so I can put that over there. Now I could fill in the gaps with 0. So 0 plus 0 there, 0 there, and 0 there. And we simply have to add 0 plus x cubed y is x cubed y. X cubed y squared plus 6x cubed y squared is 7x cubed y squared. Xy cubed plus 0 is xy cubed. Xy minus 2xy is minus xy. X plus 0 is x. The 1 and the -1 will get cancelled. And 0 plus y is y. And that would be the final answer. So we have two polynomials. One is longer than the other. So I'm going to put the longer polynomial as the first one. The next one has negative x raised 5, so I can put that here. It has an x raised 4 term, so 2x raised 4. It doesn't have an x cubed term, it doesn't have an x squared term, but it has a -3x, so I'm going to put that on the side. It has a number, which is 1. Now I just have to fill in the gaps. So 0, 0, 0, and just add. The x raised 5 and the negative x raised 5 would go away. 10x raised 4 plus 2x raised 4 is 12x raised 4. 5x cubed plus 0 is 5x cubed. Negative 10x squared plus 0 is negative 10x squared. 8 plus 1 is 9. 0 plus negative 3x is negative 3x. As I mentioned earlier, it's always better, or it's the proper way to write a polynomial in decreasing powers of x. So we will have 12x raised 4 plus 5x cubed minus 10x squared minus 3x plus 9.